Recall that angles determine terminal points on our unit circle. Here we have our angle theta, which determines the following green point, and terminal points on our unit circle determine right triangles. Here's our right triangle. Using these right triangles, we can determine values of our trig functions by definition. And an important thing to notice is the sign of these values are determined by the quadrant of our terminal points. In this example here, sine theta is going to be positive in quadrant 2, whereas cosine theta is going to be negative in quadrant 2. A way to remember this is with the following chart. In quadrant 1, all trig functions are positive. In quadrant 2, only the output of the sine function is positive. In quadrant 3, only the output of the tangent trig function is positive. And in quadrant 4, only the output of cosine will be positive. Another interesting fact about trig functions that arise from the unit circle is that the value of trig functions evaluated at non-acute angles will have the same value as trig functions where we evaluate it at acute angles. The only difference that will appear is the sign. To evaluate trig functions at non-acute angles, we're going to reintroduce the idea of a reference number, and in this case, we'll be calling it a reference angle. Let theta be an angle in standard position. The reference angle, theta bar, associated with theta, is the acute angle formed by the terminal side of theta and the x-axis. In this picture up here, the reference angle theta bar associated with theta is given by this angle here. In example 1, we'll find the reference angle of a few different angles. Let's find the reference angle of the following 3 angles. In part A, we'll be looking at theta is equal to 5 pi divided by 6. We can start off by drawing our xy plane. And then let's draw the angle theta that we're given. Since theta is given to be 5 pi divided by 6, this is greater than pi divided by 2, but less than pi, which means our angle is going to lie somewhere in the second quadrant. The associated reference angle is then going to be formed by the negative x-axis along with this green ray here. This is going to be theta bar. Theta bar is equal to pi minus 5 pi divided by 6, which is equal to pi divided by 6. In part B, we're given that theta is equal to 10 pi divided by 6. Again, we can go ahead and just sketch a picture. Here we have our xy plane. Let's go ahead and draw our angle. 10 pi divided by 6 is greater than pi. And we can go ahead and check to see if 10 pi divided by 6 is greater than or less than 3 pi divided by 2. Multiplying 3 pi divided by 2 by 3. This is equal to 9 pi divided by 6. This means that 10 pi divided by 6 is greater than 3 pi divided by 4, which means our angle theta is going to wrap all the way around and be inside the fourth quadrant. The associated reference angle, theta bar, can then be found by taking 2 pi and subtracting our 10 pi divided by 6. And the result, we can simplify this to be 2 pi, or say 12 pi divided by 6 minus 10 pi divided by 6 is equal to 2 pi divided by 6, which is pi divided by 3. So the reference angle in this picture is given by pi divided by 3. In part C, we're given that theta is equal to 23 pi divided by 7. Again, we want to find the reference angle. So what we want to do first is we just want to see exactly what a coterminal angle of 23 pi divided by 7 is, where that coterminal angle lies between 0 and 2 pi. So we can do this pictorially first, and then we'll do it algebraically. So initially here, we have a 23 pi divided by 7, and one revolution around the unit circle is given by 2 pi. That means is 14 pi is going to take us all the way around the circle. 14 pi divided by 7 will take us around the circle once. Then 21 pi divided by 7 will take us around 1.5 times. And then we're left with just 2 pi divided by 7 left. So if we follow it around once, here's our angle for 14 pi divided by 7. Now we go around a half trip around the circle. And then we end up with, there's a little bit left over. Where there's a little bit left over is given by 23 pi divided by 7 minus 21 pi divided by 7. The green curve, the red curve, and the black curve correspond to 23 pi divided by 7 as an angle. And as it turns out, when we were simplifying our angle, we found the reference angle. The reference angle in this case is theta bar is equal to 2 pi divided by 7. Now that we can find reference angles, we're able to evaluate non-acute angles inside our trig functions. There's multiple ways to do this. The first way is to draw out the unit circle, find the reference angle and the associated right triangle, then determine the value of our trig function from that right triangle. Another way to do this is to find the reference number and then draw the right triangle. Again, find the ratio that corresponds to that trig function, and then determine the signs by the chart that we saw at the beginning of the section. Let's go ahead and do a few examples. Example number 2. Let's find the following values of the given trig functions. In part A, we want to determine the secant of 120 degrees. In part B, we'll be looking at tan of a negative 4 pi divided by 3. In part C, we'll be looking at cosine of 4 pi divided by 3. And in part D, we'll be looking at, let's say, sine of 120 degrees. In part A, let's first convert 120 degrees into radians by dividing by 180 degrees and multiplying by pi. Simplifying this, we should get that this is equal to 2 divided by 3 pi. So the value that we're looking for is the secant evaluated at 2 divided by 3 pi. Drawing a picture along with our unit circle, we can now go ahead and determine the angle. We know that the angle is going to lie in the second quadrant, which means the point on our unit circle lies on the second quadrant. This is going to determine the following right triangle. Now we need to go ahead and find the reference number. Again, since we know that theta is 2 divided by 3 pi, then the reference number is going to be obtained by subtracting pi by 2 divided by 3 pi. And we're left with pi divided by 3. So our reference angle over here is a pi divided by 3. This makes our right triangle a 30, 60, 90 triangle. The radius is length 1 then. The opposite side is given by the square root of 3 divided by 2. And the adjacent side is given by a negative 1/2, because our triangle is pointing out in the negative 1/2 direction. The secant is defined to be equal to r divided by x. In this case, r is equal to 1, and x is a negative 1/2. And so the value is going to be equal to a negative 2. Okay, let's look at part B. In part B, we want to go ahead and look at tan evaluated at negative 4 pi divided by 3. Since this angle is given in radians, we don't have to convert it. let's go ahead and draw our picture. So here's our unit circle, and this is a negative angle. So we're going to again start at the x-axis, but it's going to open up in the clockwise direction. Since this angle is smaller than a negative pi, this is going to lie in the second quadrant. Again, to find a reference angle, what we need to do is we need to just subtract a negative 4 pi divided by 3 by our negative pi. So a negative 4 pi divided by 3. And what we're left with is a positive pi divided by 3. And then we can form our right triangle, and we know that this is a 30, 60, 90 triangle, where again, the reference angle is given by pi divided by 3, or 60 degrees. So the adjacent side has length 1/2, the opposite side has length square root of 3 divided by 2, and the radius has length 1. Tan theta is defined to be opposite divided by adjacent, which is then equal to the square root of 3 divided by 2 divided by 1/2. This is equal to the square root of 3. And I forgot to say that this x value here is a negative 1/2, which means that this is a negative 1/2, and so this is a negative square root of 3. Okay, let's look at part C. In part C, we're looking for the cosine evaluated at 4 pi divided by 3. Again, this is in radians, so we don't need to convert it. We can just go ahead and draw our unit circle. And we know 4 pi divided by 3 is greater than pi, but less than 3 pi divided by 2, which means our angle is going to lie in the third quadrant here. To find the reference angle, this is going to be determined by theta minus pi, which is 4 pi divided by 3 minus 3 pi divided by 3. The reference angle in this case is again pi divided by 3. So theta bar is equal to pi divided by 3. And we can form a right triangle with this angle here. So this is our theta bar here. Since theta bar is again 60 degrees, this is a 30, 60, 90 triangle. The adjacent side has length negative 1/2. The opposite side has length negative square root of 3 divided by 2. And the radius has length 1. Cosine of 4 pi divided by 3 is equal to adjacent, so x divided by the radius. This is then equal to a negative 1/2 divided by 1, which is just negative 1/2. Let's look at part D now. We're now looking for sine evaluated at 120 degrees. And we saw in the first step that 120 degrees is equal to 2 pi divided by 3 radians. So this is going to be sine evaluated at 2 pi divided by 3. Drawing this angle, we see that this lies in the second quadrant here. Here's our theta. And again, theta bar can be found by subtracting theta from pi. So pi minus theta is equal to theta bar in this picture, which means theta bar is going to be pi divided by 3. Again, this forms a 30, 60, 90 right triangle. So here's our theta bar, which means the adjacent side has length 1/2. The opposite side has length square root of 3 divided by 2. And since we're sitting inside the unit circle, the hypotenuse will have length 1. Calculating sine, this is equal to opposite y divided by the hypotenuse, 1. So this is just going to be the square root of 3 divided by 2. And notice the only thing that was negative here was the x value, but the x value wasn't defined for our sine theta, and so we get a positive sine theta.